Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our learning of CO2 sequestration modeling using CMG software. And as you can see, now we are in our folder. In previous videos, I have shown you cases of CO2 sequestration with structural trapping only, and then combination with hysteresis trapping. And what happens if we have structural and hysteresis trapping in infinite aquifer? And what happens if we add water injection? So now we move to the next exercise. And in this particular exercise, we will add up solubility trapping. So it's another trapping. Okay, in addition to structural and hysteresis trapping, now we will apply solubility trapping, which will enhance the quality of the trapping of the CO2. Okay, the CO2 will be dissolved into the aquifer, into the brine, making it trapped permanently, so to speak. Okay, all right, and maybe we will have two cases in this particular subject. In this video, I will show you the case with Lingham's method, and in the next exercise I will show you the case with Harvey's method. Okay, so let's go ahead. We will borrow the wind prop from the structural case. So I copy this one and then I will paste it here, and I will rename it as wind prop case 3. Okay, because case 2 doesn't involve wind prop. Case 2 just borrow wind prop from case 1, but now in case 3 we need to modify our wind prop. In this case, CO2 or maybe structural hysteresis now plus solubility. Okay, and let's copy this one. Okay, and yeah, maybe we can just go directly to the wind prop. Okay, so now we are in CMG Technologies Launcher. I will go inside the 3A folder and then just drag and drop it on the wind prop. All right. Okay, so now we are inside the wind prop. First, go to title and just change it to, I will call it case 3 and then structural plus hysteresis plus solubility. Perfecto. And maybe we can add Lingham's method. Yeah. Okay, we will maintain the Peng-Robinson 1978 equation of state, and we will also maintain the unit. We need kPa and degree Celsius centigrade. And now we will go to check it a little bit. Remember, we have two components, CO2 and methane, CH4. And by the way, we are in the component selection properties. Okay. Now we go to aqueous phase. Talking about solubility trapping, we will also talk about aqueous phase. Okay. And here, when I'm talking about method, I mean is about the Henry's law constant correlation. You can use either Harvey's method, which is a newer correlation, or the Lingham's method, the older one. We will start with Lingham's method, okay, for the Henry's law constant correlation. Henry's law constant correlation is something that involves the diffusivity, okay? Diffusivity of course, it will influence the solubility of the CO2 entering the, entering the brine, entering the water. Okay, so it will depend on the parameter called Henry's law constant. Okay, so that's very easy. Now let's go to CMG GEM EOS model. Okay, we need to check the option of aqueous solubility parameter output, and we need also to enter the reservoir temperature and pressure. So print component properties for GEM to WinProp 3. Okay, good. We will keep the reservoir temperature for the GEM fluid model of 50 centigrade. Good. We will maintain the Rocho aqueous density correlation as well as the Kestin aqueous viscosity correlation. But now we will check this one, print aqueous phase component solubility parameters, and recalculate solubility temperature at temperature and pressure, in this case in reservoir temperature, and our reference pressure. Okay. Okay, and don't forget to save. All right. And we need to run it. This is the simulation output. Okay. This will be actually similar to the output from the previous case, the WinProp for structural case only. But now we will have solubility parameter. Okay. Maybe we can, we can check it here, or we can also go to the produced file of the result. But maybe I will check it here first. You see, this is the Rocho aqueous density and Kestin aqueous viscosity. You can see the, you can see the keyword. And now we have solubility keyword there, and temperature 50 degrees centigrade, and pressure 11,800. Okay, and the other will be the same, perfectly the same with the structural case only. Okay, so again, I want to save, and we can leave the WinProp. Okay, so we are back at the CMG technology launcher, and as you can see, after we run the WinProp, we produce the files here, .gem, .out, and .srf. In particular, .gem will be used for the further simulation, the reservoir simulation. Okay, and maybe we can check the .out. The first is the .out using the solubility trapping case, and we will compare it with the structural case. WinProp. We'll check it with the .out here. Okay, let's open the .out for the structural trapping. Oh, sorry. What I mean is actually we need to compare the .gem, not the .out, but the .gem. So here, .gem for structural case, and now I will open the .gem for the solubility trapping case. Okay, so now let's compare them both. Okay, so as you can see from the name here, we have the .gem from structural case only, and .gem produced by WinProp for solubility trapping. Okay, in particular, we go down to, on the right, something called solubility here. Okay, so in WinProp, we only select solubility feature, and then we also say that we will use Harvey's method. Okay, and after we run on the WinProp, it will produce .gem, and the gem will produce some keywords like something that we have here. Okay, We do not have this in previous case, as you can see here, right? Here we have omega A and omega B, perfectly the same with on the left. But on the left, after omega A, omega B, and paracore parameter, we go down to enthalpy coefficient. But here, we have something before the enthalpy coefficient, and now we have solubility. That's the difference, and it is a massive difference. If we run the new case with solubility trapping, now we equip with solubility trapping, the result will be very, very different. Okay, we need to check solubility keyword, Henry's constant keyword, calculated at 50 degrees centigrade. Okay, and then this is Henry constant. This is not keyword, this is a comment, and this is the Henry's constant, keyword. This is the value for CO2 and CH4, and V infinity. Okay, and this is, if I'm not mistaken, this is reference pH. Okay, the Henry's coefficient for C1, we need to enter it to be 0, so that simulator will skip the solubility calculation for the methane. So let's change it manually to 0. Okay. All right. And so far so good. Now, another thing that's very, very important, don't miss it. We need to copy this one. Okay, we need to copy. We can close this one. We need to copy this. Okay, and we need to add it up into the .dat of our simulation file, the .dat. Okay, which will be put on the gem later to produce the reservoir simulation. Okay, I will maintain it. And now let's go to 2A case. This, can I rename it to be, or maybe later? Here, I will copy this one and then I will put it here. I need to rename the file. Okay, let's go down to here. Let's rename it 3A and then plus solubility. This is the .dat of the builder, right? Of the model, not the fluid model, .dat of WinProp. This is .dat for the builder, for the reservoir model. Okay, so I rename it to 3A, structural hysteresis and solubility, and open this .dat, and also open the WinProp. Okay, we will copy this. Okay, from WinProp, and then we put that on the end of the fluid model. Okay, where is it? End of fluid model. Maybe we can put it here, right? We are still inside the fluid model. I will copy the solubility case, the solubility keyword here, and then I will save. It's wise to change the name as well. 3A, structural hysteresis plus solubility. Perfecto. Okay, and make sure you save, close, make sure save, close. Now go to CMG technology launcher, and as usual, let's run it on the gem. Okay, just go directly, click on OK, wait for a while until we have the .sr3 and the .out. I will show you at the end of this video, I will show you the .out, and on the next video, we will show you the the results, the visualization. It will be very, very interesting. Still running. Okay. Almost there. The SR3, the size is already 1000 kilobyte, so it's correct already. Okay, complete. Let's review the .out first. Okay. Let's go to the bottom. The results at, let's say, the year 2223. Okay. What we want is, as usual, the CO2 storage. Yeah. Well, summary at reservoir condition after, this many days. CO2 already in shut-in well condition. You see we have CO2, CH4, and H2O. Let's check it here. Okay. CO2 storage amount in reservoir, gaseous phase, no CO2 in gaseous phase, no CO2 in liquid phase, but all CO2 will be in supercritical condition. Yeah. And now we have dissolved in water. Beautiful. Right? We have dissolved in water, and we don't have this value in previous case. Yeah. Let's check the dot out. Go down. It's the case structural and hysteresis trapping. You see there is no dissolved in water amount, but after we add solubility trapping, we have dissolved the CO2 inside the water. Beautiful. All right. Okay. Now another thing that's very important is, of course, to visualize the results. But I think we can close it here and go to the next video. Okay. So thank you so much for watching. I hope you enjoy this learning. I hope this learning is useful for for all of us. See you again, and thank you so much.